There is a set of straight lines in a plane such that each line intersects exactly 10 others. Which of the following could not be the number of lines in that set? So we're going to draw a bunch of lines on the plane, and what we want is the property that each one of these lines individually intersects exactly 10 of the other lines. So do have a go at this problem. We've been given five options here: 11, 12, 15, 16, and 20. I'm going to dive into a solution here. So with this problem comes from a senior maths challenge paper, and with senior maths challenges and UKMT problems, sometimes elimination helps. So that's what we're going to do to get a feel for what's going on here and also to potentially eliminate some options. What we're going to do is draw some lines on the plane. So I'm firstly drawn towards this option here, 11. If I'm going to draw 11 lines on the plane with each line intersecting with 10 others, that means that each line has to intersect with every single other line. How is that possible? Well, one way it's possible is if I draw all 11 lines kind of going through the same point. So obviously that's not 11 lines, but imagine I continue doing that so they all pass through this center point here. Let me pick on this line, for example. This line is one of the 11 lines, so there's 10 other lines, and it very clearly intersects all the other lines precisely at this point here. And so 11 is possible. It is possible to draw 11 lines such that every single line intersects 10 other lines. So the answer can't be A. Okay, cool. Let me get rid of these options, that drawing. So it can't be A. Next thing I'm going to look at is 20. Another kind of relatively intuitive thing to try is what if we draw kind of 10 uh, vertical lines? So I just draw five and I draw 10 horizontal as well. So again, I've just drawn five for simplicity. This also has the property that I've drawn 20 lines in total, so 10 vertical, 10 horizontal. And if I pick on this line, for example, it does not intersect with any of the horizontal lines, and it intersects with every single vertical line, which would be 10. And so this is true for all the horizontal lines, and a very similar thing is true for all the vertical lines. So that means 20 is possible, so it can't be 20. Okay, cool. So we've eliminated two options. Now, we've played about with this. We've eliminated two. But what actually is going on here? What we realize is straight lines are going to intersect precisely is dependent on whether or not they are parallel. So if I have two lines, one line and the other line, they are going to intersect if and only if they are not parallel. So let's look at option 15, for example. It turns out 15 is possible, and so we can eliminate 15. Let's see why 15 is possible. Let's draw a line. So this is going to be one of 15 lines. Now, this line here has to intersect 10 other lines, exactly 10 others. So that means that there's got to be 10 lines in my collection of 15 lines, 10 lines which are not parallel to this guy. But if I've got 15 lines in total, that means that there's got to be four other lines that are parallel to this one. So let me just go over that again. I'm going to draw 15 lines on the screen. This is going to be my first one. So there's 14 others to go. Now, because we know that this line, let's give it a name, L, we know L1, let's say L1 is parallel, sorry, it's perpendicular, sorry, not perpendicular, but just not parallel to 10 other lines. But if there's 15 lines in total and L1 is only not parallel to 10 of them, it must therefore be parallel to the other four here. So that means that there must be four other lines that are parallel to it. So one, two, three, four, and then a fifth one, five. Okay, cool. And now we know that this is kind of a family of parallel lines, and there can't be any other ones parallel to it. So let's draw in another line which is not parallel to these, this guy here. Well, we can, if we call this L2 maybe, we can apply the exact same logic we did to L1 to L2. L2 has to have four other lines in the plane which are parallel to it. So maybe this guy, this guy, this guy, and this guy. Cool. So far we've got 10 lines out of our 15 drawn. We now need to add an 11th line, which is neither parallel to L2 nor L1. Let's just draw, I don't know, this line here and call it L3. And now we can apply the same logic that there must be 4 other lines parallel to L3. So maybe this line, this line, this line, and this line. And lo and behold, we now have a total of 15 lines. With each line, let's pick on L3, for example. That L3 is not going to intersect any of these guys, but it's going to intersect all of these guys and all of those guys, making 10 intersections. And you can apply that logic to any one of these lines. So that means that 15 works. So therefore, we can eliminate 15. What exactly have we done here, though? We've realized that since we've got 10 lines, we want each line to intersect with 10 other lines. If there's a total of n lines, so we just looked at when n is 15. If there's a total of n lines, we therefore need n minus 10. This number here is going to be kind of the number of lines in each family of parallel lines. So here we looked at when we drew 15 lines in total. And if we look at this kind of family of parallel lines, those 5 there, well, there's precisely 5 of them in there, which is 15 minus 10. Same thing here. The number of lines in a family are 15 minus 10, which is 5.
Pause! I've decided to set up my own tutoring company to help you study maths at a top university. So if you like the way I explain things, go check it out. Let's get on with the video.
So in order for this to be possible, in order for it to be possible for us to draw this up, we need n minus 10 to be, or 15 minus 10 to be a multiple of 15. A factor of 15. And it is. So 15 minus 10 is 5, and 5 is a factor of 15, which means that we can get precisely 3 groups of 5 lines. And we see that this is the logic that we have to apply here. If we look at the case of 12, 12 again, it turns out that it is possible. So let me just get rid of all this. If we look at n is 12, oh, I shouldn't eliminate it yet. N is 12. If we have a line, now it has to be not parallel to 10 other lines. And so therefore there must be another line here, which it is parallel to, because if there's 12 lines in total, to this line L1, there are 10 lines which it's not parallel to. That gives us 11 lines in total. There's still 1 left, which it has to be parallel to, say this guy. Cool, let's now add in a second line, L2, and again we can apply the same logic. And so here we can see the parallel lines are coming in groups of 12 minus 10, which is 2. And so in order for this to be possible, 12 has to be a multiple of 2, and it is. So what we can do here is just do 6 sets of pairs, or 6 pairs of parallel lines. So there's our third pair, maybe there's our fourth pair, maybe there's our fifth pair, and then here's our sixth pair of parallel lines, and you can check, but each individual line will intersect exactly 10 other lines. So it's not B, and so therefore it should be 16 is our answer. So if we get rid of 15, it should be 16. Let's just confirm that. 16 minus 10 is 6, and 16 is not a multiple of 6. So 6 does not divide into 16. And so that's why it doesn't work, because if you try to do it with 16, you need to have parallel lines coming in families of 6, but you can only then do 2 of them, which is 12. You can't then make it up to 16. So this is really, really interesting. I enjoyed playing about with this problem. It's a nice little nugget to kind of come across, and I encourage you to now generalize this. What if I change this number 10 to k, and look at the case? Can I draw n lines in the plane such that each line intersects with exactly k lines? So do have a go at this problem. Let me know in the comments down below what the solution is to this. Thanks so much for watching. I'll catch you in the next one. Have a great day.